Okay, a company's constraints on its three inputs, x1, x2, and x3, lead it to conclude that the general solution is t, 6 minus t, and t minus 4. For their business, each input must be non-negative integers, which makes logical sense. We can't output -6 apples or we'd be in debt. So use this to determine all the possible values of the constraints as ordered triples. Okay, so just a reminder, the constraints are x1, x2, and x3. So we're trying to find all the possible values of x1 and x2 and x3 using these values of t and this little bit of information right here, that they must be non-negative integers. That's probably the most important bit of information in this entire question. So what that means in more general terms is that it has to be equal to 0 or greater than 0. It can't be negative. So we know that x1 has to be greater than or equal to 0, x2 has to be greater than or equal to 0, and x3 has to be greater than or equal to 0. And given that we have this right here, we can expand that information and say that since x1 is equal to t here, we can say that t has to be greater than or equal to 0. x2 is equal to 6 minus t. So 6 minus t, I'm just going to draw these arrows here so we know where we're getting that from. We know that 6 minus t has to be greater than or equal to 0. And we know that t minus 4 has to be greater than or equal to 0. Okay, so now we have some pretty good statements about t. We've learned a lot about t here. I'll go ahead and erase this here. So we've learned a lot about t, but it's still not as simple as we'd like it to be. So I'm going to go ahead and take this bottom statement right here about t, and we're going to rewrite it in a way that makes more sense for us. So we have t minus 4 has to be greater than or equal to 0. So we can balance this out. We can move some stuff around to just make it a little bit more intuitive. So we can move the 4 from this side to that side. So we can add 4 over here, add 4 here, and those cancel out. So now we have t is greater than or equal to 4. Okay, so what we did is we just rewrote this here in a more simplified way. So I'm going to go ahead and replace that original sentence with our simplified one. All right, so we know now that t has to be greater than or equal to 4. And now let's go ahead and take a look at that top statement right here. We said that t has to be greater than or equal to 0, and then we said that t has to be greater than or equal to 4. Well, 4 is a fair bit greater than 0, so this t is greater than or equal to 0 statement is already contained within this t is greater than 4 statement, because 4 is greater than 0. So that makes this top statement not irrelevant, but we can go ahead and just erase it because it's already in that bottom statement. It's already contained within there, so we don't need to write it out again. Okay, so we understand that about t now. So let's take a look at this other statement about t. And I saved this one for last because I did make a mistake on this one earlier, and it's one that I've made a lot. So we're going to do a very similar process for this right here. We're just going to restate this in a way that makes more logical sense to us. So we'll say that 6 minus t has to be greater than or equal to 0. So I'm going to go ahead and run through that same process that we did before, but I'm going to make a mistake on purpose, and then I'll show you why we can't do what I'm about to do. So most of this is going to be fine. There's going to be one little step that trips everything up. So we're going to move that 6 over like we just moved that 4 over. So minus 6 on this side, minus 6 there. All right, we cancel those out. So now we have negative t is greater than or equal to negative 6. And now, since there's negatives on both sides, we'll just go ahead and cancel out those negatives. So we'll divide by negative 1 here and divide by negative 1 here. And then those negatives cancel out. So now we have t is greater than or equal to positive 6. And this step right here was the mistake. So let me go ahead and illustrate in a different color why that can't be the case. Most of that was fine, but there was one little slip up here. So let's say we don't know the value of t yet, but let's go ahead and say that t was 1. Let's pretend we already figured out t, and let's say that's 1. So we have 6 minus 1 is greater than or equal to 0. And this is a true statement. Now we'll go ahead and do that same operation that we did before. We'll move that 6 over. We'll subtract both sides. All right, and then we have -1 is greater than or equal to -6, and this is still true. And now we'll do that division right there. We'll cancel out those negatives, and now we have 1 is greater than or equal to 6. But that's not true at all. 1 isn't greater than or equal to 6. 6 is greater than 1. This would be true if we flipped that sign around. If 1 was less than or equal to 6, because 6 is greater than 1. So what that means is when we switch that negative sign over, when we flip the negatives, we also have to flip our logical operator, which is a fancy way of saying we have to flip that less than or equal to sign. If this was an equal sign, if this wasn't less than or equal to, this would have been perfectly logical, which is why I make that mistake fairly often. Now, maybe this is something you already know, but I went ahead and pointed it out just because it's something that trips me up a little bit. So, anyway, all that to say, we now have some accurate information about t. I'll just go ahead and erase all that. So, what we did is just to recap, we took this statement right here, and we rephrased it like this, and we made sure that it was accurate by flipping that sign. Okay, so I'm going to go ahead and erase this right here and replace it with our accurate information. So now we have t has to be less than or equal to 6. And this actually gives us a pretty good range here. So we know that t has to be greater than or equal to 4 and less than or equal to 6. So I can go ahead and write that in this sort of format right here. So we know that t has to be less than or equal to 6. And we know that t has to be greater than or equal to 4. Okay, so we have 4, something, and 6 all as good values for t. Well, basically everything between 4 and 6. And we'll scroll up here. This specifically said integers, which is a whole number, which is something I didn't really know until this year. So an integer, 4.1 is not an integer, but 4 is an integer, 5 is an integer. All of if you think of a number that doesn't have a decimal, that's an integer. So maybe you knew that already, but just for clarification. So every solid number between 4 and 6 is a viable option for t. So we have 4, what comes after 4? 5, and then we have 6. So these are all pretty good options for t. All of these would fit perfectly well for the constraints that we've been given. So let's go ahead and test those inside of all of these constraints right here, and that'll give us our ordered triplets, as it says. All right, so let me go ahead and erase most of this now that we have our information narrowed down. All right, okay, we finally got all that erased. Okay, so we said we were going to test these inside of here. So let's try, we'll start with 4. So t, we're saying t is 4. So we'll do 4, that's our first bit here. Then we'll have 6 minus t. Right now we're saying 4 is t, so 6 minus 4. And then t minus 4, we're saying that t is 4, so I have 4 minus 4. All right, and then this will evaluate out to 4. 6 minus 4 is 2, and then 4 minus 4 is 0. Okay, so this is our first of the triplets. So that's one decent, good value for t. That's totally within our range. Okay, so we just tested 4, and let me actually underline these in a different color, make it a little more clear what I'm doing. All right, now we're going to test t as 5. And we know these are going to work. We're just trying to see what they look like. So we're going to have t. We're saying t is 5. That's our first bit. And then we have 6 minus t. We're saying that t is 5. All right, and then we'll have t minus 4. We're saying that t is 5. All right, so we have 5, 6 minus 5, and 5 minus 4. And that evaluates out to 5, 1, and 1. All right, and these are perfectly fine. 0 is a perfectly fine value. 1's a perfectly fine value. -1 wouldn't be, but we went ahead and made sure that that wouldn't be an issue. All right, and now we'll go ahead and test 6 as our last value here. All right, let's see. There we go. All right, and now we're going to have t. We're saying that 6 is t. All right, and then we'll have 6 minus t. We're saying that 6 is t. All right, and then we'll have t minus 4. We're saying that 6 is t. So we have 6 minus 4, and then this evaluates out to 6. 6 minus 6 is 0, and then 6 minus 4 is 2. All right, so now these are our triplets. Let's see here. These come out to our triplets. So this is 4, 2, 0. That's one fine output. 5, 1, 1. That's another fine output. And then 6, 0, 2. And that's another fine output. So these are all the outputs that we can make with these constraints.